All right, let's talk about a new AI chip that is so mind-blowingly fast, it might just change, well, everything. We're talking about a potential new era for AI hardware. You know that feeling, right? You give a chatbot a really heavy, complex prompt, something you know was going to take some real thinking. You hit send, and then you just wait. You can almost feel it churning, see the digital gears grinding as the response comes out word by painful word. Why is it still like that? Well, it's because what we're used to is basically a snail's pace compared to this. Get this, a tiny Canadian startup called Taalas just showed off a chip that spits out 16,960 tokens per second. To put that into perspective for you, that's fast enough to write an entire novel in less than a minute. It makes AI feel truly instantaneous. And this chart, this says it all, right? Look at the sheer scale of that jump. We're not talking about some small incremental improvement here. The HC1 is over 8 times faster than a high-end chip from Cerebras, and an absolutely staggering 28 times faster than Nvidia's latest and greatest B200 GPU. So the question is, how on earth is this even possible? To really get what Taalas has pulled off, we first have to understand the huge fundamental problem they're solving. Turns out there's this kind of hidden inefficiency, a sort of GPU tax, that's been baked into AI hardware for years. And that problem has a name: the memory wall. Think of it like a terrible traffic jam. With traditional GPUs, the things that power almost all AI today, the brainy computing cores are in one place and the memory is way over in another. So to get anything done, they have to constantly shuttle massive amounts of data back and forth. All that travel time is wasted time. And if you want to see just how bad that traffic jam is, look at this. It's insane. In a normal AI data center, a whopping 90% of all the energy used goes into just moving data around. Only 10%, just a tiny fraction, is for the actual AI thinking part that we care about. It is just unbelievably inefficient. So this small team, just 24 people, they looked at this problem and decided to just tear the whole thing down. They asked a really radical question. What if we stop trying to run AI models like they're just another piece of software, and instead, what if we make the chip become the model? And this right here, this is the paradigm shift. On the left, that's your standard GPU. It's flexible, which is great, but it's always stuck in that data traffic jam. On the right, that's the Taalas approach. There is no separation between the compute and the memory, because the model's entire intelligence, all its parameters, are physically built into the chip's wiring. They're etched right into the silicon. I love this quote because it just nails their philosophy. It's a fundamental move from simulating a brain on a computer to literally building a silicon brain from scratch. The model isn't a program you run. It is the computer. And when you do that, the results are just wild. By getting rid of all the expensive parts like high bandwidth memory and complex liquid cooling, their chips are 20 times cheaper and use 10 times less power. It all adds up to what Taalas claims is a 1,000-fold leap in overall efficiency. 1,000 times. The company makes this really brilliant comparison. They say this moment is like the shift from ENIAC, the first room-sized general computer, to the invention of the transistor. ENIAC was amazing, but it was a one-off, totally unscalable. The specialized transistor, though, it made computing cheap, fast, and put it everywhere. That's the goal here, to make AI inference as common and inexpensive as plastic. Okay, but, and you knew this was coming, there is a huge catch. This incredible performance comes at a very, very high price. To get this kind of speed, you have to give up something the entire industry considers sacred: flexibility. So here's the deal. A Taalas chip that's been etched with the Llama 3.1 model can only run Llama 3.1. Forever. It can't run anything else. This creates a massive risk of what's called model obsolescence. The minute a bigger, better AI model comes out next month, this super fast custom chip instantly becomes a very expensive paperweight. And just look at how fast things change. This is Nvidia's own public roadmap. They're planning a new, more powerful generation of AI hardware every single year. In an industry that moves this quickly, betting the farm on a single permanent model feels like a huge gamble. So how does Taalas plan to solve this massive obsolescence problem? Well, you guessed it, with another radical innovation. They knew that if they were going to make hardware that's essentially disposable, they had to make it incredibly fast and incredibly cheap to produce.
And this is their answer. 2 months. They've built this completely automated system, almost like a software compiler, that can take a brand new AI model and generate a complete, ready-to-manufacture chip design in about a week. The total time from a new model existing to having a physical chip in your hand is just 2 months. This lets them do what they call seasonal hardware. You could literally print a new chip for every new model that comes out. So what does all this mean for the future? Well, it suggests we're coming up on a major fork in the road for AI, where the hardware market could split into two very different directions.
On one path, we'll keep the massive flexible GPU data centers we have today. They're perfect for training new models and for doing research. This is the AI we wrench from the cloud. But on the other path, we could have these hyper-specialized, super low-cost, low-power chips designed for deployment. This is the AI we own, running right on our devices with basically zero delay. And that second path unlocks all sorts of applications that just aren't really possible with today's cloud-based AI. Think about robots that can react instantly, or AI agents that can perform hundreds of thinking steps in a split second to complete a task. These kinds of applications need that near-zero latency, which is exactly what these hardwired chips deliver. And that brings us to the big, final question. For decades, we've thought of computing power as a service, something we subscribe to. But this technology opens up a totally different possibility. It suggests a future where powerful, specialized intelligence isn't just a service in the cloud, but a cheap, hardwired commodity that's literally etched into the silicone of our everyday lives.